difference of perfect squares is, like I said, the easiest form of factoring, I think. But we need to be able to recognize what a perfect square is. So let's go through our numbers. We need to know up to 13 what 13 squared is. So let's start with 1. What's 1 squared? So is 1 a perfect square? Yes. What's the next perfect square? 4. What's the next one? 9. It's 3 times 3, not plus. 3 times 3 gives us 9. What's 4 times 4?
16.
5 times 5? 6 times 6? What's the next one? 49. Then?
64.
Then 100. What's 11 squared? 12 squared. 13 squared. 169. 169. Okay? All right, you need to know at least up to the 13 squared. Be able to recognize what perfect squares are.
That's all you gotta do. What if it isn't like that?
Well, the first thing you're going to look for is there a greatest common factor? Because once you take out a greatest common factor, you may be left with a perfect square. And if it's not, then it's prime. You can't do anything else with it. You just stop. All right? Like here, 4 is a perfect square, right? But x is not. So this is all I can do right here. Here, first we look for greatest common factor, which there's none. Then we decide, because it's the difference, is y squared and 100, are those both perfect squares? Yes, they are. So I know I'm going to have plus minus. Now I've just got to figure out what the square root of these numbers is. Y times y, 10 times 10. Very, very simple. What about this? Is it two positives? Okay. Okay, well, it can't be 2 plus signs, because that would be y squared plus 10y plus 25.
Wait, what?
If I foiled this back out, this is what I get. That's not the same thing as this. Okay? It can't be 2 minus signs, because then I'd have this. And that's not the same thing as that. So you're saying it's got to be 1 plus 1 minus?
Yes.
All right, well, that gives me this, which is not the same thing as that. It's prime. You can only factor the difference of 2 perfect squares. The sum of 2 perfect squares is not factorable. It's prime.
So it can't be addition?
No, because if it's addition, then you're not zeroing out that inner and outer term, you're doubling it. Because it's not plus 5 minus 5. It's now plus 5 plus 5. Okay? So the signs have to be different, which means it has to be subtraction. All right, now suppose I asked you to factor this. I've been saying it at the beginning of every problem. What should you do first? Find a greatest common factor, because as it stands, 3 is not a perfect square, and neither is 75. But 3 and 75 can both be divided by 3. So if I factor out a 3, now what do I have? perfect squares. The difference of perfect squares. Remember, this is a puzzle. We're taking the pieces apart. 3 is still a piece. And the difference of perfect squares factors down to 1 plus 1 minus. And what's the letter and the number involved? X and 5. And you must have all the pieces of your puzzle because you want to be able to put the puzzle back together and get the final picture. Okay?
What if you have two, what if 3 is a 9, and then 75 is like 100?
Okay, let's do that. Are those two terms, is there something you can multiply by itself and get get 9x squared? What? 3x and 3x? Isn't that 9x squared? And then 10 times 10 is 100, right? 1's plus, 1's minus. So it doesn't, this first term doesn't have to be just x squared. It could be a combination of letters.
Wait.
It could be numbers and letters. Yes.
Is that, what if that number's not like, can't be squared?
If the number is not a perfect square and you cannot remove a greatest common factor, then it's prime.
The first one?
Yes. Well, the whole thing would be prime because there's nothing you could do with it. Okay? They either have to both be perfect squares or you need to be able to take a common factor out of both of them to make them both perfect squares. Otherwise, it just stays like it is. Okay. Can you take out a greatest common factor? Yeah. They are both perfect squares as they stand, but we're going to have to take that GCF out eventually. So let's do it in the beginning. What is it?
4.
Can we keep going? Yes. 4x to the 4th is a perfect square. Okay, now look. Well, let's go ahead and do this one. That's 2x squared times 2x squared. They have to be exactly the same. It's 1 times 1. 1's plus, 1's minus. Okay, now here's where Nick's question came in. Here, x squared is a perfect square. 1 is a perfect square. They're being subtracted, but where's the problems? This 2 is not a perfect square. So this cannot be taken any further. That's your final answer. Okay? Those 3 factors are what you would put back together to get 16x to the 4th minus 4. Early, you have none?
She told me I have to get a note from my mom, and she said bring me another one.
Gotcha. Okay. It's not prime. First, look for a greatest common factor. Well, 3. 3 goes into 3 and 48. And you keep going. Yes, you can. So keep going. There you go. You're done. Remember, greatest common factor first. All the time. That's the first thing you look for.